We are going to be talking about trig ratios. Okay, and trig ratios are really what you see at the bottom of this page here, which is going to be your main sine, cosine, tangent values that we see. The other three, there are 6 trig ratios that we have worked with and maybe not seen cosecant, secant, cotangent yet. I'm not sure how far they went with physics for you. I'm guessing just sine, cosine, tangent. But if you remember, sine, cosine, tangent, we briefly did this on the first day. We drew a right triangle for ourselves, and we said in any right triangle, if we are looking at an angle, and we'll call that our angle here, the side directly across from that angle is known as the what side? Opposite. The side across from the right angle is known as the hypotenuse, and our leftover side is our adjacent side. Good. So how did we represent sine then? Sine of our angle is equal to opposite over hypotenuse. And I want you to write that whole equation there. A lot of us are just used to writing sine equals O over H. There is always an angle in here, okay? That's going to be our degree or our radian, depending on what we're talking about. So you always need to have that angle in there. So then if I do cosine, we know cosine of the angle is equal to what over what? Adjacent over hypotenuse. Good. And then the last one we're familiar with is tangent. Okay. Yep. Tangent of an angle is equal to what? Opposite over adjacent. The good news with the 3 that you don't know, these are known as the reciprocal identities. Okay. Reciprocal means what? Flipped, yes. The reciprocal identities are just flipped from the ones across from them, okay? How I remember these, cotangent should be easy to remember, that it's the opposite of tangent. The other 2, I remember that the first letters can't go together. So sine cannot go with secant because they both start with S. So sine has to go with cosecant. So that means if I'm doing the cosecant of an angle, its abbreviation is CSC. Cosecant of an angle simply flips the sign, which means it's going to be equal to what? Hypotenuse over opposite. Good. Secant. Secant's abbreviation, SEC, of an angle is equal to the flipped version of cosine, which is going to be H over A. Okay. Cotangent then is COT, flipped version of tangent, which is going to be adjacent over opposite. Okay? The other thing that you have to remember is reciprocal literally means that you flip them upside down. So when we think of our unit circle and we think of our points on there, okay, I'm literally going to take the sine value from the y from that point that we've been memorizing, and I'm going to flip it upside down. Okay? So you don't even always have to remember the hypotenuse over the opposite or draw yourself a triangle for this. Reciprocal literally means you're flipping it upside down. The other thing we're going to have to discuss is how to find the tangent from the sine and the cosine. Okay? But first we're going to practice on the next page with just setting up a triangle. All right? So if you flip the page over, there's a couple different ways of things that you can be given in order to set up a triangle. Okay? First, I can give you a point. If I give you a point in order to set up a triangle, okay, you know where this point is located. This is just an XY point. So that means from the middle of my graph, which way would I go? Right? 6. So I would go right 6 and up how many? 8. Okay? That gives you 2 sides of a triangle. Where do I finish drawing my triangle? Okay, from the origin to the ending point, because this is the point 6, 8 out here. Okay, so that, when you are given a point, is how you draw your triangle. Okay, now when we said we were doing right triangle trig, we have an opposite side, we have an adjacent side. What do we need still? Hypotenuse side. Okay, anyone remember your Pythagorean triples? A squared plus B squared equals C squared, right? So anytime you don't have a third side, you can use that. Yep, this is a Pythagorean triple, which means you should know the third side is 10. Okay, That makes this easy for us to set up our 6 trig identities for this one. All right, so you have 6 trig identities. We're going to set up sine of the angle, we're going to set up cosine of the angle, and we're going to set up tangent of the angle first. Okay, you are not solving anything with this. You are setting up a ratio. A ratio is just a fraction. Okay, so we said sine is equal to what over what? Opposite over hypotenuse, which in this case is what over what? 8 over 10. We always reduce, which means it's actually going to be equal to what? 4/5. All right, let's try that with cosine. Cosine is equal to the adjacent over hypotenuse, so in that case it's what? 6 over 10, which reduces to 3/5. Tangent is opposite over adjacent, so in this case 8 over 6, or 4/3. Any issues with those 3? Okay, that should make it easy for us to set up the other 3 because they are simply the reciprocal identities. So, what's the reciprocal of sine? Yep, cosecant. Okay, we're going to set up cosecant, the reciprocal of sine. We're going to set up secant, the reciprocal of cosine. And we're going to set up cotangent, the reciprocal of tangent. All we are doing is the reciprocals. So that means if I take the reciprocal of sine, I'm going to flip that and make it what? 5 over 4. I'm going to flip the cosine, making it 5 over 3. I'm going to flip the tangent, which makes it 3 over 4. That is all we are doing right now, is setting up the 6 trig identities. Issues with that? Why are these numbers that I haven't seen in the unit circle? Okay, we don't recognize any of this from the unit circle. What is, if I was to draw a circle using this point as the outside of it, okay, what is the radius of that circle? 10, right? Because from the center out to the edge is 10. What's the radius of the unit circle? 1. So the unit circle is a very specific set of sines, cosines, and tangents. Okay? These do not have the same radius, so you're going to have different values. So some people immediately try to go into finding the angles and figuring out where this is in the unit circle. Okay? We will very specifically be telling you when it is the unit circle. Okay? It will say sine of 30 degrees or sine of 60 degrees, and it will not refer to any other triangle that we're working with. Okay? So if they give you information to draw a triangle, go ahead and do that, but make sure you only use the unit circle ratios for ones that actually have a radius of 1. Okay? Let's try that again with number 2 real quick. In number 2, we are given a little bit different information, and the reason we want to deal with this one is because of the square roots. We have a lot of square roots when it comes to the unit circle, so we need to practice dealing with them. First off, these are sketches. They are not specific drawings. So if I'm given the point -4√2, what quadrant am I in? The second, right? Because a negative goes to the left for x, and a positive, no matter how far it is, goes up for y. So these graphs, you're not going real specific on them. You are just drawing -4 backwards and up √2. Okay? We then complete our triangle with the hypotenuse. You always, always, always want to draw along the x-axis first. Notice I've always drawn the x part first, not the y. If you do the y part first, it'll orient your triangle the wrong way. We want to be using reference angles for this. Okay, reference angles always go with the x-axis. Okay, how then am I going to find my third side? Pythagorean theorem. It does not matter what is a and what is b. So I can do √2 squared plus -4 squared equals c squared. It just matters that I know c is what I'm missing, right? If I square √2, what's that going to give me? 2. If I square -4, it's going to give me 16. So that means c squared is going to be equal to 18. And when I square root both sides and simplify the square root, what is c going to be? 3√2. All right, this means we're going to have to reduce square roots on this one, okay, by hand. So when I set up my sine, let's do that first. Okay, I will show a lot of work on these, and you're going to see why in a minute for when you do your reciprocals. I know you don't have to show all your work. Number one, if you show me work, I can give you partial credit. If you don't, can't help you. So these are good ones to show work on. So secondly, if you show all your work, it often makes it easier to find the reciprocal. Okay, so if I'm doing sine, what's the opposite side? Root 2 over 3 root 2. Okay, what happens here with my roots? They cancel, which leaves me my sine is what? 1/3. Good. Let's try the same thing with cosine. Cosine is adjacent over hypotenuse, so that's going to be what over what? Okay, now may I leave it this way? No, because there's a square root in the bottom. Who remembers how to get rid of that? Multiply by the square root, top and bottom. Not the whole denominator, just the square root. So I'm going to multiply by root 2, top and bottom. If I do that, that gives me -4 root 2 over, what number am I going to get on bottom? 6. Because root 2 times root 2 is 2. And then times 3 gives me 6. Finally, I reduce any numbers outside the square root, which in this case is -2 root 2 over 3. Good. Last on this side is your tangent. Tangent's your opposite over your adjacent, which in this case is what over what? Root 2 over -4. Can I reduce that? No, because the 2 is inside, the 4 is outside. Now, here's the reason we showed all of our work. Some of these, that's going to make it easier to find the reciprocals. Okay, sine, the reciprocal should be easy for cosecant. If I do the reciprocal of that, what's that going to give me? 3. For secant, here's the real reason I showed all of my work on that one. If I take this ending answer that we just had and I flip it, what am I going to have to do? I'm going to have to simplify it again. I'm going to have to multiply by root 2, top and bottom, and then reduce, and it's going to be a big mess. What else could I flip that would make my life easier? The original. If I go back to this original step before I fixed that one and I flip that upside down, do I have to do anything? No.
Would you get the same?
You would get the same thing. It would just take you a heck of a lot more work. So that's why I show my work on that one, because I can look back through my mess and find an easier way to flip it. Okay? Now, tangent, when I flip that one, I am going to have to do some work. There's no way around that one. If I flip that one upside down, it puts the root 2 on bottom. How do I get rid of that? Multiply by root 2, top and bottom. That gives me -4 root 2 over what? 2. And then last but not least, I reduce the numbers outside, which gives me -2 root 2 as my answer. I reduced -4 over 2 there. Okay. Questions or issues on that?
Are most of the ones we get going to be like the complex one or like good?
It'll be about half and half, probably. Mainly with this, these are going to be big point problems when you have these. Like this is like a 10-point problem because that's a lot of work. What I will do when I grade a question like this, okay, first and foremost, I will grade what you have drawn on your graph here. So, for example, if you screw up your graph from the beginning, what does that do to all of your answers? Screws them all up, right? So, I will take points off on the graph for like messing up finding the hypotenuse or messing up what quadrant it's in, which screws up your negatives and positives. I will not, however, then go take all of the points off for your answers. I will go back and look at your answers and say, did you set them up correctly for your drawing? Okay? So on a 10-point problem, you could lose 2 points for messing up your picture. But if you set up the all the 6 trig identities right, you're still going to be fine. Issues with that? Make sense? That also means if you like have no idea how to set up your triangle, you can draw me a little note over here on your graph and say, I wasn't real sure about how to draw this, so I picked a couple numbers and set one up, and I'm going to use that to set up my answers. Because you're still showing me I might have missed the drawing skill, or I don't know where to put it, And that's a skill that I'm going to take points off for, but you can still show me how to set them up. Because there's two skills here, and there's really no way to separate them for me. Okay? Does that kind of help with how to do this? All right, there's two ways here to be given information. You can be given a point, or you can be given what we see on the next page. Okay? All right. What you are given here, okay, you are given quadrant information, plus you are given one of the trig identities. Okay? Now, first, let's talk about what this means. This is telling me a location. Okay? They will not always tell you a specific quadrant, but this one has. Okay? This is saying your angle is between 3 pi over 2, 2 pi. What quadrant is that telling me it's in? 4. So when I draw my picture, I know my triangle's in quadrant 4. You must be careful how you draw your picture. How did we say or what side did we say we draw first? The X side. So that means when I draw my triangle here, I'm going to draw along the X, down the Y, then complete my triangle. Okay? Never, ever, ever draw these triangles along the y-axis. It's just like reference angles. We only use x's. Okay? Now we interpret what we've been given here for our sine value. They've given us a sine value. What this does is it gives me two sides of the triangle. Sine is known as what over what? Opposite over hypotenuse, right? All right. So, they're telling me in this triangle, the opposite side from my angle is what? -5. My hypotenuse is going to be what? 13. Here's what usually gets everyone. You have to interpret where the negative goes. All right? If I'm drawing this triangle, I'm going to the right on the x-axis. That means my x side is going to be what? Positive. Then from there, I'm going down into the fourth quadrant, which means my y side should be what? Negative. A small hint that will help you, the hypotenuse is never negative. Ever. Okay? Your x can be negative, your y can be negative, your hypotenuse cannot be negative. All right? So because I have those two sides, how do I find my third side? Pythagorean theorem. So a squared plus b squared equals c squared. What's going to be my third side? 12. All right, take a minute on your paper here and set up your 6 trig identities. Do you have to set up sine? You can, but you don't have to. They gave it to you. Okay?
The sensation of falling without
No. All right, real quick, just to go through answers on that. Unfortunately, I just erased my drawing. All right, real quick, going through answers for this one. Your sine should be equal to -5 over 13, which is what they gave us. Your cosine should be equal to 12 over 13. Your tangent should be equal to -5 over 12. From there, you're just doing reciprocals. Cosecant flips that, you keep the negative. Secant flips cosine. And tangent, or cotangent, flips tangent. Any issues with that one? All right, last one like this, and then we're briefly talking a little bit more about your unit circle. Question number 4 tells you two things. It tells you the secant value. It also tells you that you are between pi and 2 pi. So quickly here on this one, if it tells me that I am between pi and 2 pi, where was pi? All the way to the left at 180. 2 pi is all the way to the right. So they are telling me that this is somewhere in which of 2 quadrants? 3 or 4. Okay? If they tell me 3 or 4, okay? This is telling me quadrant 3 or 4. I have to interpret what this is telling me. All right? Secant. All right? A lot of you are not going to be as familiar with the reciprocal ones, so you can think back and say, if it's secant, what is it the reciprocal of? Cosine. Okay, if secant is negative 2 over 1, what is cosine? Negative 1/2. If cosine is negative, cosine is adjacent over hypotenuse. If the adjacent has to be negative, which quadrant are we in? 3. I was looking at the wrong one on that one. Yeah. Okay, so if the adjacent has to be negative, you have to be in quadrant 3. Again, this is one of those where if you mess up the drawing, I'm going to take points off for that, but not kill you on the whole thing. Yes, sir. Why is it quadrant 3? Because if the adjacent has to be negative, I could draw a picture like that, or I could draw a picture like this, right? The adjacent is that side either way, okay? If I go to the right, that's going to give me what kind of x value? Positive. If I go to the left, it's going to be negative. All right, so when I do that here, that means this side's going to be negative 1, and my hypotenuse is going to be what? 2. If I have the adjacent side and the hypotenuse side, I have to use Pythagorean theorem. Okay. In this case, I'm going to do negative 1 squared plus b squared equals 2 squared. So that's going to give me b squared equals 3. And that means that my opposite side is going to be equal to what? Square root 3, and here's also where you have to be careful. When you square root, do you know whether you have a positive or a negative answer? No, you have to interpret based off your picture. I went left, which gave me a negative x, and then I go down into the third quadrant, which means it's going to be negative root 3. That's where a lot of people will lose like 1 point for forgetting the negative there, because that's a tough one to kind of remember. And then we set up from there. So sine. Sine of the angle is opposite over hypotenuse, which is going to be what? Negative root 3 over 2. Good. Cosine of your angle. Negative 1/2. We know that one already. Tangent of your angle. Okay. Negative root 3 over negative 1, which just reduces to what? Root 3. Then we do the reciprocals. The reciprocal of sine is cosecant. If I flip that upside down, it makes it 2 over negative root 3. If I can't leave it that way, and I multiply by root 3 over root 3, it's going to give me 2 or negative 2 root 3 over 3, right? The negative can go top or bottom. It doesn't really matter. Secant, we already know because we were given that. And cotangent, what am I flipping? I'm flipping root 3. So what's that going to look like? 1 over root 3. So then when I multiply by root 3, top and bottom, it gives me what for my cotangent? Root 3 over 3. All right. Questions on that? All right, last thing we're talking about is the next page briefly. Yes?
Is it 1 over negative?
There's a negative over a negative for the tangent, which made it a positive. All right, last page we're talking about here. All right, the reason we talk about all of this is so that we can talk about the 6 trig identities for our special angles, which is our unit circle. Okay? Special angles means unit circle. Okay? All right. So, to practice this briefly, you can use the unit circle to help you find trig ratios for any of these without drawing triangles. So briefly, let us write in the points for the 4 quadrants. At 0, the point was 1, 0. These should be the easy points, no matter whether you memorized all quadrants or not. What's the point up at the top? 0, 1. What's the point to the left? Negative 1, 0. And the point at the bottom? 0, negative 1. Remember, our points, our x and our y, correspond to what? Cosine and sine. All right, now, in order to help us, there's a second way to represent tangent. Tangent is also equal to sine over cosine, okay? This is the final piece in the puzzle that allows us to do all 6 trig ratios from just memorizing our points. If we know our sines and our cosines from our points, we can flip those to get our cosecants and our secants. We can divide them to get our tangent and flip the tangent to get the cotangent. Okay, so let's just start briefly with an easy one. Sine at 180. I go to 180 degrees, and which of those two am I looking at? The second one is the sine, so that means my sine of 180 is what? 0. Second easy one there, cosine at 180. I'm looking at the x or the y? I'm looking at the x, the -1. All right, now, before we do C, I'm not jumping into C real quick. Yes? It's 0 because the y value at 180 is my sine from this right here. The y value is my sine, the x value is my cosine. So I went over to 180, I looked at that point, and I said the sine is the 0, the cosine is the -1. The x is the cosine, the y is the sine. No? In every single one of these points, the x value, that's the cosine of that angle, and the y is the sine of that angle. Always. This angle over here is 180 degrees from our unit circle. So if it asks me sine at 180, I go over to 180 and I look at the y value, and that is my answer. Okay? All right, before we do the tangents and the cotangents, okay, let's look at E. Cosecant. Cosecant is the reciprocal of which one? Of sine. Okay? The S ones, yeah. All right, so if I want to do the cosecant at pi over 2, where's pi over 2? At the top. Okay, so I go up to the top and I look at this point. Which one of those is my sine?
1.
The 1 is my sine, the y value. So if I want to do the cosecant, that's the reciprocal of 1, which is what? 1. Let's do the same thing for part F. Okay, secant is the reciprocal of what? Cosine. So if I want to do the secant at 2 pi, where's 2 pi? All the way here to the right. Okay, which one of those is the cosine? 1. What's the reciprocal of 1? 1. All right, now before we do cotangent in part C, let's do tangent. So here's the ones we haven't done yet. If I want to do the tangent at 90, 90's up here again. We have to use our other representation for tangent, sine over cosine. So to find the tangent at 90, I do the sine divided by the cosine. What's the sine there? 1 over what? Can I divide by 0? No. What's my answer? Undefined. You can. I'm going to always abbreviate it with a 0 with a slash through it, but that's me. Okay, last but not least, cotangent at 270. Where's 270? At the bottom. Cotangent is the reciprocal of tangent, so I would find tangent first. Tangent is sine over cosine, or you can flip that. So if I did sine over cosine, that's going to be -1 over 0. I want to do the cotangent, which means I do what? 0 over -1. So what's my answer for cotangent there? 0. You can do this with any angle in your unit circle. Okay, so when we look at the bottom half here, okay, bottom half, any other special angles we're looking at. Okay, if I was to do 45, let's remember from our unit circle quiz today, what is my point for 45? Root 2 over 2, root 2 over 2. Okay, which one of those, the x or the y, is my sine value? It doesn't matter in this case, but I want you to know which one it is. The y is my sine, so that makes that root 2 over 2. Which one of those is my cosine? The x, root 2 over 2 for that. What's the easiest way to find the tangent? Divide them. Sine divided by cosine. This looks hard. It is not hard. Why is this not hard? They're the same thing. Anytime you divide the same thing by itself, what is the answer? 1. Which means what's the cotangent? 1. Because it's just the reciprocal. How do I find the cosecant from the sine?
Flip it and multiply.
Flip it and simplify. So if I flip it, it gives me this. Multiply by root 2 over 2. Root 2 over root 2. That gives me 2 root 2 over what? 2, which cancels and gives me. Okay. Now if I was to flip the cosine to do the secant, do I have to do the work all over again? No, I don't, because I just did that work.
Magic.
Okay? So you may do this for any point on the unit circle. Okay? Let's try one other one, and I promise I'm done on the next page. Well, I don't want to leave you doing this without knowing how to do this. 5? Why 5? There is none? Number 3. Tricky, tricky. All right, what was the point for 30 degrees? Root 3 over 2, 1/2. Which one of those is my sine? 1/2. Which one of those is my cosine? Root 3 over 2. Okay, so you could start with flipping those to get your reciprocals, or how do I find my tangent? Divide. If I'm dividing 1/2 by root 3 over 2, how do I actually divide fractions like that? Keep the first one, and what do I do with the second one? Flip it and multiply. Okay, if I do that, what's going to happen? I'm going to have a root 3 on the bottom and a 1 on top. Okay, how do I fix that? Multiply by root 3 over root 3. This gives me what for my tangent? Root 3 over 3. Again, I showed all of my work there because what would it be very easy to flip for my cotangent? The original or this one right there. Okay? I can flip that, which makes my cotangent what? Root 3. I don't know why I wrote a 2 there. Excuse me on that. That's a 3. If I flip the sign to give me the cosecant, what's that going to be? 2. And if I flip the cosine to give me the secant, I'm going to have to do a little bit of work here. What do I multiply by? Root 3 over root 3. So that's going to give me 2 root 3 over 3. Now, when we start doing the chart in a little bit more detail next class, you're going to understand why. Because there are patterns to these, and if you know how to do them for the first quadrant, you don't have to repeat it for every single one. It's the same type of work. It's just got negatives or positives with it instead of what you've seen here. Okay? So for homework on this, we're going to do page 29 through 31 all. Okay? Now look at page 31 for me. 29 through 31 all. Okay, this page right here. Okay? Here's what I want you to write on the top of page 31. No decimals. Okay? This means you are not doing this page in your calculator at all. Okay? Yes, I know you could go directly to the filled out chart in your notebook and write down all of these answers. Will that help you in figuring out what the heck they are? No, they won't. What I would do, okay, notice that all of these are either quadrant angles or they're angles from the first quadrant that you already took a quiz on and know. I would fill out a unit circle up in the first quadrant and do the 4 quadrant ones. The sine is the y value, the cosine is the x value, the tangent you divide your sine by your cosine. This is what we just did. Okay, just did right now. So if you show up in here and you give me decimals out of your calculator, they're going to automatically be wrong because they are not what I want. I want square root answers, and your calculator will not give you those. Okay?